Brian. I thank you, everyone, for being here midway through TechCon Day 2. I'm Brian Wilson, your host for the API Management and Gateway track. Hope you're fueled, inspired, and ready for our next topic. I'd like to introduce Ricky Morehouse, who will cover AI-powered API testing. But first, remember, submit questions in the chat. Please ask questions. We want to make this as interactive as we possibly can. So ask the questions, take the poll, the survey at the end of the session, and we'll all learn together. Take it away, Ricky.
So, hi everyone, I'm Ricky Morehouse. I'm a cloud architect for IBM API Connect, and as Brian said, I'm going to be talking today about AI-powered API testing. So first of all, let's step back a bit before we start going into the how AI can help us here. I mean, why do we want to test APIs in the first place? I mean, there's a number of ways we can do it, but if we start from the very basics, the reason we want to start testing our APIs is to be able to deliver high quality APIs faster, with less effort, and to be confident that when we make changes, we're not going to break anything as we roll out those changes to our consumers. So we may start off with in the development process with mocking an API, so simulating the API responses to help speed up some of the creation. So someone may be building a client or an application and need to have access to the data. So we might start off by building that API as a mock rather than going into the full definition of the application and the implementation. Then once we've got that working, we can then take that and move forward to create an API, design and develop that. And as we're going along, we probably want to make sure that that continues to work as the application expects it, according to the specification and according to what our users of that API are expecting from it. So we want to make sure we're doing this testing for our APIs, all stages of the API development lifecycle. So in development, where we're starting out building the API, we probably want to do some iterative testing along the way. We may have a new microservice that we're building. We may be replacing an existing one. Being able to test iteratively as we're developing helps us find edge cases as we go, identify behaviors that aren't correct early in the process so that we're less likely to see those problems as they progress through the pipeline towards production. Then once we've got the API working as we like, got it implemented, we'll probably promote it to the test environment where we want to move to some sort of more formal level of testing, guaranteed scenarios that are part of the contract, the particular use cases that our applications are expecting from that API, and build out a suite of test cases for how we expect the API to be used. And then we can use those guaranteed scenarios as part of that CI/CD pipeline to make sure that we don't break things going forward. We know that those golden scenarios are things that continue to work as we go from test through to pre-prod, and then from pre-prod into production. And in production, we want to be doing some testing to identify gaps. If we see something that's being done on the API that we're not expecting, we may want to take that and import it into our test suite to ensure that that behavior that we see consumers using continues to work as expected, even though it wasn't necessarily part of that original scenario that we'd thought out. And the other place we may want to do testing in production is to monitor that things continue to run as expected. So no changes in behavior there through unexpected environmental issues. And if we've got the test cases that we've built in the test environment in a way that we can reuse them through pre-prod and sometimes in production as well, it saves us time from having to do all of these in separate ways for the different environments. So in API Connect, we've got a couple of key features in the space that help with this. For the iterative testing in development, we've got Auto Test Assist. And in the later stages, we've got Smart Generation, which helps build out a test case for you from your API specification. So instead of having to build this from scratch and define all the requests and assertions yourself, this will build out a framework for you from what's defined in the API specification and the Open API spec, and use that to build out the test case from setup through testing and assertions to the teardown afterwards. And they can be then reused across the lifecycle. It may be that it doesn't give you everything, but it should save you some time in getting started and getting set up and building that. And I'll show you how both of these work in a bit more detail as we go on. So first of all, auto test assist. So this is the one where I'd say we'd use primarily for the iterative testing in development. And it starts from your Open API specification. All of this is Open API specification based. And what it will do is it will take all of the endpoints and methods that you've got within your API, and it will build out a set of thousands of biased random requests that can be fired off at your API implementation without having to create individual test cases, without having to build out sample data. And you can customize which endpoints it prioritizes on, whether it's injecting errors, how many test cases you want it to run at any time, how long you want it to run for. So you could use it for a short test as you're developing something, adding functions and seeing how the endpoints are behaving, catching those unexpected behaviors, fixing them, rerunning, and seeing how it works there quite quickly in an iterative development process. Or you could leave it running for an hour or so and actually test your API with lots of traffic. It's not designed as a load test, it's designed as sort of fuzz testing across the API. But you can get that wider range of scenarios fired at it without building out those requests. Then the second stage that I mentioned is the smart generation. And this is where we go from the random to the more structured. And this will take your specification again, and it will work through understanding all the different methods within the specification and analyze how they fit together, how those different endpoints and methods can be used together as part of a multi-step flow to build out a test case. So for example, if you've got a bookshop API where you're getting a book, in order to get that book record, you need to have that record there with an ID. Normally, when you're building out tests like this, you'd have to create a suite of test data, make sure that that's kept up to date with your schema, up to date with your tests, and then inject that into all these places so that you can actually test that in each environment. Each one would have to have that set of test data to make sure the tests are working against that data. Whereas what smart generation does here is it saves you that time by looking at the methods. It says, okay, you've got a get for this book ID, and there's also a post to create the book. So it will add a post request in first to create the book based on what's in the schema using your object definitions. Then it will do the get, generate a whole bunch of assertions based on how you've defined the API in your Open API specification. And then after it's done, it will call if they've got one, it will call a delete method to clean up after itself. So that test data is no longer left in the system, which makes it reusable without having to have the data separate to the test. And I'll show you in a demo now how these two can be used in practice. And if you want to scan the QR code on screen or go to the ibm.biz/API testing, there's actually a lab guide for the steps I'm going to take you through in the demo, so that you can actually work through it yourself in our SaaS environment on a free trial and explore a bit more about how this works for yourself. So let me switch over to my browser. This is my instance in the SaaS environment. Just make sure my session hasn't timed out. Okay, and to make things quicker, I've already imported the Bookshop API specification here. And we can see if we expand the paths section, we've got a number of different paths. So we've got some things around books, some things around customers, and some of the services. And if we look at the customers endpoint, we've got just a single post. Let's have a look at customer ID. There we've got delete, get, and put. So we've got a few different methods, a few different paths. So that should give us enough to start testing this with. And I've got a sample backend that I've started to develop here. Now, the scenario that I'm basing this around is I'm building out a new API. We had a previous version, maybe written in a different programming language or using some older frameworks, and I'm working on porting this to a newer set of code. So my API backend is in development. I know what the specification is. I know how it should behave. And what I'm going to do is use this as a step towards iterative development to find some behaviors that I'm not expecting in these APIs. So let's create a test suite to contain all these from today. And we'll go in here. And to get to Auto Test Assist, we go to the Auto Test Profiles tab. And then you go to Add. And we can choose either from any of our APIs that we've got within API Manager as the starting point, or we can import a separate specification. So I'm going to go for the sample bookshop API. And then it will generate this extension file based on what it sees within the OpenAPI specification, going through all of the different types of properties, what the definitions are like, different resources and how they're related. You can then customize this later, but usually you won't need to. And let's save that as bookstore auto test assist. And we'll give it a tag for dev because I'm using it in dev. And then next. So then I'm going to edit that. I then have some configuration about how I'm going to run this test today. So first of all, I need to get the endpoint that I'm going to test. So just give me a second. And I'll get that endpoint. And this is all contained in the lab guide if you want to do this yourself. So there's a sample endpoint that's available to use as well. So I'm going to change this server URL here with my sample dev endpoint. Then we've got some details on when we want this to stop. We say how long we want it to run. I'm going to go for up to 3 minutes. Maximum number of requests, I'm going to leave as unlimited. Because this is early in dev, I'm going to go for, let's have 10 maximum errors, and then it will stop soon after that happens. It does, as we're doing parallel requests, we may get to more than 10, but it'd be around 10. We can then choose whether or not we want to deliberately inject errors. I'm going to run it first without, then we'll come back and run it with. We can then specify particular resources that we want to give a higher level of weight to. If we're focusing on a particular resource or particular instances, we can then also choose whether we want to focus on particular operations. So, for example, if I'd just been adding the post operations into this, I might want to tell it to focus more heavily on post. If I'd just done gets, I could tell it, let's just stick with gets to start with. Now, depending on your schema, you may need to specify some overrides here as to particular content types. So if there's a particular validation that you'd have, and in some of these books, once I get further in the implementation, I'd probably need to do something like that for the ISBN number, once I get the validation added into my API implementation. So now let's kick that off and start that running. It will now save the test and then start generating calls in the background. So see, we've got up to 13 errors, so it should be stopping shortly. So because it's got the parallel threads running with the tests, it's a few more than that. So we can then get this nice clear report of how things are working. We see services category is looking good. There's no warning icon there, so that's all got successes. We can click through and see what posts it made, all those calls to the services category, and we can see that it's using the post, passing the content type. and a generated text string for the title and getting a 200 OK back, which fits with the spec. So we're all happy there. We clear that, we can then see all of them. I'm going to go back to the overview. On these ones, we see we've got 2XX errors. So it's returning a 2XX series status code, but it's not matching what's expected from the OpenAPI specification. So let's have a look at customers and see what's going on here. Okay, so invalid property, first name's not allowed, last name not allowed, email not allowed. So quite a lot of properties not allowed. So what it's sent here in the request, we've got a post, we've built up this body, it's got a realistic looking username and textual strings for the others. And the response was a 201. So I think you'd expect when you're creating it, but it's sending the data back. So I think that's what's not expected. So the specification is not expecting us to include all the data, but it is expecting us to send a UUID back as the customer ID. And if we look down here, we're not getting the customer ID back, and we're just echoing back what was in there. Now, this is because in this case, I've got a very early stage development backend to test against. Then I would go back and iterate on the code, make sure I've implemented the function to return the customer ID, and I'm not just echoing back any responses. So that's a useful thing to find. Let's have a look at one of the others. Let's see what services usage has. Okay, so service must be one of the following: author or category. Service is author was in the post, so that's looking good. Service is author in the body. I'm intrigued as to what's happened with that one. That's not what I was expecting. So there's the sort of things you can look at, and then I think I'd need to go and look into the code and see exactly what's going on there, why that was deemed an error, compare the code to the spec. But this is giving me a good sense of where I want to do those comparisons. Now, as I said, we can then tell it we want to inject errors. So let's submit some known badly formed requests as well. And let's go for a higher level of error percentages and run this test again. Hopefully this time we'll start to see some of the error cases pulled out through the reports where we're trying things that we expect to fail. It may be that my implementation doesn't have enough error checking in it, so I get success results when I should get failures. But again, that's useful, valuable feedback in development to know that things aren't working as expected. And combining this with building out a back-end implementation using AI assistance like Watson Code Assist gives you a really powerful way of iteratively developing API implementations. So this time we've got some errors from the books endpoint, and there's lots here. So the format's wrong for the date. The format field's not got the right values. So we see what data we've sent. We've generated some random text for some of the fields, and as I say, ISBN is one that we could add some dynamic types in to tell it this is what an ISBN looks like. But we note that because in our spec we've got enums for the format, we've got a valid format. Because it's a date, it's done something in a date format. Now, sometimes a date like that would fail validation and probably should. In this case, it's sending the body back. And I think, again, I haven't implemented the return response as expected in the specification. So it gives that warning here. So that then gives me something to go and look at in my application code. So that's the auto test assist. And there's a few areas that you can explore and tweak it and fine tune what it's doing. But it really does give you that quick way to make a series of requests against the API based on what the specification is asking for. So let's move ahead now and say, assume this API was ready to take further and move it into my test environment. I then want to start building out some test cases for the specific scenarios that I'm expecting here. So now I'm going to use Smart Generation to build some tests from the specification. Again, I can pick any of my APIs within the API manager. I'll stick with the sample bookshop API for now. And this time we'll pick one of the get operations. We'll go for get of a book. Let's give this a name. So we'll get book by ID. Tags on it. Oh, I spelled book wrong. We'll just go for get and TechCon. Then once we go through here, it will go through analyzing that specification. As I said, identifying the related functions within there so that we can see how easy it is to build out a full test case ready to validate the API's functions. Now, this is taking a little longer, but here we go. We've got a test case generated. And here we go. We've got the global variables to set for our endpoint. So again, I can populate those with the details of my backend that I've got in development. The reason these are variables because you might want to put them into a data set, so you could have a set to run it once across different environments. But in this case, I'm just using my development instance still. You can specify a default book ID if you want to, because it's picked that up as a key value. But then we've got this request that it's done first. It's found the post request for creating a book, generated some sample data within the test. You can then tune this, adjust it as needed. And then once it's done that, it's storing the output from that in the variable books. Then it does a get request for the same host details /books/books.bookid. So that's taking the book ID that's returned from that first request and doing a get on it. And then we've got a series of assertions that have been built together based on the specification that we put in. So we expect it to give us a 200 status code. We expect this content type to be application JSON. And then we expect all these different fields to exist. So we want it to have a title, we want it to have an author, and we want the author to be a string. And it goes through everything in that specification data object, make sure that that's in there. And then after it's done all that, we've got another request to do the cleanup afterwards and to delete the book with that book ID from that first request. So I'm going to save this and run it. I expect it to fail because I haven't fully implemented my backend yet. But if I had progressed to the point where I was ready to start promoting this, I'd probably see some success here because I'd have iterated more in the previous phase. So here we go, the post, I've got a 201 back. That's what I'd expect. But then when I do a get, I'm getting a 301 for it, which isn't as expected. And because of that, I'm also not getting the application JSON. So let's have a look what we got back from the post. So request body looks reasonable. That's what we expected. Yeah, I'm not sure what's gone wrong there. I think it's probably something missing in my back end as it's early days in the development. But then you see what it could do with building out the different stages of the test. And because the get failed, we haven't gone on to the delete. So you can then go and look into what's happened, why it's there. Then once you've got these tests, you can, as I say, you can tune them, adjust what it's going to do, make sure that you've got all the data types right. And then you can publish them ready to be used as part of a CI/CD pipeline. You can take these tests and download this file and use it with the Apex CLI as part of an offline pipeline, or you can use the webhooks to trigger them within API Manager itself. So that is smart generation at a glance. And let me just switch back to my slides. So as we saw with Auto Test Assist, we can create a auto test profile from an API specification that represents the logic within that API, makes it able to make multiple requests, thousands of sample data to call your API and validate those behaviors, all based on the specification. And then you get the test report that gives you a nice summary of everything that it found with the details of each request. And then on the smart generation side, we've got that ability to take the spec and build out a request for a particular function within that spec, and to build out the multi-step test with creating test data, testing it, and then cleaning up afterwards. So thank you all for listening. That's a overview of our AI testing capabilities in API Connect, and some ways that you can use it to help you more quickly iterate and develop APIs.
All right, thank you, Ricky. Questions? Got plenty of time. And ask them live. Someone must have a question.
So I think if no one's got any questions, I'd be interested to know maybe some questions in the answers in the chat. What sort of percentage coverage do you think you have of your API in forms of testing today?
Anyone willing to share some answers? We don't have a talkative group today, but that's okay. If you want to talk, please do join office hours, 2:30 p.m. Eastern today. Our speakers will be there. You can talk about any of the topics around API management or gateways. Please do take a minute and fill out the poll question. These are the survey questions to help us improve the sessions and TechCon in general. So please take a moment and complete that before you leave and head to your next session. And anybody who wants to answer what Ying just put up, again, please do so. He asked, again, Ying's from IBM, so he's asking, how many of you are, really actively testing your APIs today? So all good questions, and again, that kind of feedback helps us formulate, where we go with things like this, right? How best
Yeah,
can we help you?
really valuable to see if there are particular gaps that you're finding, or areas where what we're doing fits or doesn't fit, to help us guide where we can make this even more useful and valuable to improving that
Absolutely.
API development and testing process.
All right. Well, again, we certainly hope to see you at office hours. Take the survey. Also, join an IBM Tech Exchange community to stay in touch. It's a great place where you can continue these discussions. Access blogs from our product management team, our developers. Great content there. And hopefully we see you live in the next session. Thanks for attending.